Yeah, hi, welcome back. We stopped at we started to introduce ourselves to compound interest in the last video. So we'll continue from there into compound interest proper today. So compound interest is basically the interest that is calculated on the basis of the initial capital or principal and the accumulated interest. All right, so I already said that the other time, and then the way it works is like I explained in the other video as well. So you're looking at if you're investing in a particular asset, financial asset or security, or maybe you're lending out your money. So you're looking at, okay, if I'm doing that for like 3 years, so that means I'm going to get my money upon maturity, like after 3 years. And the way it is calculated, it's not actually simple interest because you look at, I invested this amount of money, I got this interest in this year. And when you take it to the following year, then that's going to be initial capital, the principal I invested this year plus the interest I earned becomes the new capital for next year. Then the interest rate works on it, and on like that. So that's how it goes. Now let's assume that I invested about let's say I invested 100,000, which I think I did. I'm not sure at a particular period of time in 100,000 naira, like for 2 years. Like inside, okay, let me say I invested 100,000 in an investment for a year, right? So then that's going to be a simple interest since the interest rate is 35% per annum. Per annum. So I'm going to be having my P is 100,000, 100,000. T is 1. Then my interest is 35% per annum, which is 0.35. Okay, so how much did I earn at the end of the day? Recall this formula. A equals or what was the worth of my investment at the end of the year? So if it was how much did I earn after, then that would have been the interest. But what was the worth? Then that's the amount, like the principal plus the interest. P1 plus, we derive this, right? P1 plus R, I think RT over 100, yeah. Okay, this was the formula of A that we derived in the previous lesson. So A is going to be 100,000, 100,000 into bracket 1 plus 0.35 into bracket 1, then close the whole thing. So A is 100,000, 1 plus 0.35 times 1, 0.35. So this is 1, A is 100,000 into bracket 1.35, and this is going to give me 135,000, which means at the end of the year, since I did it for 1 year and the interest rate was per annum, right? So this is what I'm supposed to get. But I remember, let me now say I did the investment for 2 years. So we can now be like, okay, 2 years. Then that means after 2 years, I should be getting, after 2 years, I should be getting this. One after, let me call this A1 as time one. Then as time two, so I should be getting 135,000 multiplied by 2, and that will give me is it 135? No, 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 it's not that I should be getting. I should be getting this 100,000 into brackets 1 plus 0.35. Then the time here, this is time, RT time 2. Okay. I knew I don't use the 100 because I've converted the whole thing to decimal. So A2 is now going to be giving 100,000 into brackets 0.35 times 2, that's 0.7. Okay, 0.7, so I'll be having 1.7, and then that should be 170,000. Okay, so which means that in 2 years I should be getting 170,000. But like in reality, this is not how it works. Yeah, this is how it works. So in reality, after my first year, so which is what introduces us to the concept of compound interest. After my first year, so in reality, this is what I'm supposed to be having. Um, the fact that I already, like, let's assume I cashed out the money in year one, 135, and then I now want to reinvest it in the second year, like another year. So it's not as if I'm having A2, like it's still like this is just like a new investment. I'm going to be having 135,000, right? This is my new principal now because I cashed out that money then. Then I'm now investing the whole thing in the second year. Like I chose not to spend it to invest in the second year. So plus 1 plus 0.35 into brackets that new year. Like one is represent another like 1 year. Okay, close it. So A equals 135,000 into bracket 1.35. When we calculate this, I'm supposed to get 182,250. 182,250. Okay, so but for compound interest, instead of cashing out the money, like the money is reinvested on my behalf in the second year, so old principal plus new interest becomes the new principal for the second year. Then the interest is asked on it for that year. Then that continues. That process continues until the whole thing is done. So this is what I'm supposed to have. Like after, if I invest my money into a particular security, and I'm supposed to like get a return in 2 years time. So I shouldn't be expecting more 70,000. No, I should be expecting this. So what then is the formula for compound interest that captures this? Because compound interest has its own formula, just the in the same way that what do you call it? Simple interest also has its own formula. So for compound interest, we have this is it. We have this. So the amount after maturity into brackets P 1 plus R divided by M raised power MT. So that's its own formula. So what is R? What is A? A is the what of the investment after, like upon maturity, what of the investment, or what of the loan or whatever, or what of the capital, what of the invested capital after maturity. P is the initial principal or capital. One, then R is interest rate. M is the amount of times that the interest rate is compounded in that particular year. Like how many times, like are you allowing the compounding to work in a given year? So the number of times that it was compounded in a particular year, or it was compounded in a particular year. And that M also comes to act here, and T is time, right? So for like normally when you invest, the compounding happens once a year. So like M is one, right, automatically. So if the compounding is happening once a year, so you are going to be having A equals P 1 plus R raised power T, because M is 1, and then this is what you're going to have. So now let's now look at this initial investment that this guy made, that was made here, and see if after 2 years we are going to get like this answer here. So A is equal to 100,000 into brackets 1 plus 0.35 raised to power T is 2 years, 2 years. And then because we were not told the number of times it was compounded, so like it was compounded once. But if it was compounded more than once, the equation will state it. Okay, so from here, this is equal to 100,000 into brackets 1.35 square. So when you do 1.35 squared, you are going to get 1.8225. So 100,000 into brackets 1.8225. So when you multiply the whole thing out, you get 182,250. So which is same as what is here. So that is why this becomes the formula for compound interest. So you see the way it works. It's allowing you to use your initial capital plus your accumulated interest to serve as the new capital in a subsequent year, right? And then allow the interest to work on it for that year and continue. So you have this formula. So instead of us doing like these things one after the other, you do for year one, you get 135,000. Then you do the same thing like manually, 135,000, then on and on. You get 182. Then for the third year, 182 is not going to be here. Then 1 plus 0.35, 1 is still going to be here. Like, you don't need to do that. Just have this formula. So this is like a geometric expansion. So have this formula, or exponential expansion anyway. Have this. So you just keep changing the time here, and it takes you straight to the final answer. So that's that about that. So I think we have a couple of questions that we can still practice with here before we talk about continuous compounding, and then we talk about discounting. Right. So we have these guys to deal with. Just two questions. A sum of 7,000 was borrowed from a bank at a rate of 19%. What is the daily compound interest for 2 years? Now the question is asking what is the daily compound interest for 2 years, which means you must have first gotten the annual compound interest, then you have to divide by the number of days you have in 2 years, right? So again, interpretation of questions. You need to be able to interpret questions very well. And then remember that our assumption is that a year is 360 days, so 2 years should be 720 days. All right, so let's start. Of course, we know that the fact that it's even 2 years simply already tells us that's going to be a compound interest, even if compound interest was not mentioned, anyways. So to solve this, so remember that the formula for compound interest, which is A, some books can put S here, like it depends. So just like know what each of them stand for. So you have 1 plus R over M, then MT. So we don't know A, so A equals we have to get, what I'm trying to solve for A first is that let us get the entire let's get the amount, the worth of the money upon maturity. Then we subtract the principal from it. What's left is the interest. Divide the interest by the number of days, and then you have the daily interest rate. Daily interest, not daily interest rate. So P is 87,000. 87,000. 1 plus 90% is 0.19. 0.19. Okay. So here, raised power t is 2. 2 years. So what we are looking for is the daily compound interest. So A equals 87,000 into brackets 1.19 square, and A from here is going to be 87,000 1.4161. So A equals 123 200.7. Okay, so now to get interest, interest is just the same thing. So interest equals A minus B. So interest equals 123,200.7 minus P, which is 87,000. 87,000. So the interest rate here is equal to 36,200.7. All right. So the daily interest rates, I don't know why I keep saying interest rates. The daily interest equals to 36,200.7 divided by 720 days. 720 days, and then that's going to be 50.28. So the daily interest, right? The daily compound interest on average is 15 naira 28 kobo. So like that should solve that. If there's a different way you think the question may have been interpreted, you could leave it in the comment section and let us learn, from you. Like this is what I think the question is asking us to do. So for question 2, we have at what interest rate? So we don't have the R. At what interest rate would an invested amount treble? Okay, if compounded quarterly, like there's no figure for the sake of God. So what are we supposed to do? So the invested amount is P, right? So we are now saying that at what interest rate? Okay, so A would the invested amount treble. So for it to treble, then that means we are going to be having 3 times P. So A will be equals to 3P. Okay. So the invested amount is going to what's 3P. Invested amount treble if compounded quarterly. I don't think the question is complete. So there should be the number of years in 10 years. At what interest rate would an invested amount treble in 10 years? Treble in 10 years. Okay, so we have time. Time is 10. So our time equals 10. T equals 10. So this question says if compounded quarterly. So and quarterly, that's like 1/4. Right? So if compounded quarterly, so you're looking at 4 times. If it was compounded 4 times in a year, the first January to let's say March. After that it was compounded and compounded 4 times in a year. So we are looking at so the normal formula is A equals P into bracket 1 plus R over M raised by MT. But from this question, we know that what we are looking at is when this money triples or trebles. So A is going to be 3P, right, equals to P, then 1 plus R. Do we have M? M is 4. Okay, because that's quarterly, 4 times. M is 4, then raised to power 4 times 10, the formula MT. So 3p, we can just make things easy. We can just like quickly divide this by p by p. So this is going to cancel out. So we have 3 into brackets 1 plus, this is going to be 0.25 r raised to power 40. Okay, so now what you now have to do is that on both sides, divide both sides by the power of 40. Divide both sides by the power of 40. So you have to be careful, kind of, if you are not that good in mathematics. So what we have here is going to be 3, what we have here normally is 3 raised to power 1. So you have 3 raised to power 1 divided by 40 equals everything here, 1 plus 0.25 r 40 divided by 40. So like take this power out. So we can easily do 3 raised to power 1 over 40, which is 3 raised to power 0.025 or thereabout. Yeah, 0.025, then into brackets 1 plus 0.25 r. So you can get the answer for this. 3 raised to power 0.025 is going to give us 1.028 equals, you can't add this please because there's no r here. So don't say 1 plus 0.25 r is going to give us 1 plus 25 r. So just leave them the way they are. 1 plus 0.25 r. It's looking simpler. 1.028 minus 1 equals 0.25 r. And then we have 0.028 equals 0.25 r. And then r equals, divide both sides by the coefficient of r, which is 0.25. 0.028 divided by 0.25, and then r is going to give us what is that answer again? 0.11 0.1114, thereabouts, 1114. So you multiply the answer by 100 and then we have 11.14%. So this is just trying to let us know that the interest rate required for any amount, right, any amount to treble itself, if it was to be compounded quarterly over the period of 10 years, right, it's going to be 11.14%, right, any amount. So as long as that amount is going to treble, and then these conditions are going to hold. Okay, so then there's going to be an assignment that would be a combination of simple and compound interest. Yeah, after now, but before we go into that, in the next class we'll be talking about discounting and continuous compounding. Discounting and continuous compounding. So let's wait for the assignment before we bid ourselves goodbye. Given a principal of 120,000 at 6% for 3 years, find the future worth of the principal if compounded. A, we have annually, semi-annually, and then quarterly. And number 2, determine the rate of return required to have money double in 6 years when compounded semi-annually. Determine the rate of return required to have money double in 6 years when compounded semi-annually. And number 3, the cost of food has been rising by 3.6% per annum. So what can a family with current expenditures on food of 20,000 naira per month expect to spend on food each month in 6 years time? So then the next one, how long, let me just kind of change to 4 years time so it doesn't make as if I have something to do with 6. How long will it take money to double at 12% interest? So this one might take you more of a research. 12% interest rate under annual compounding. So how long will it take money to double at 12% interest rate under annual compounding? So if you have this one, just know where to apply logarithm, like a lane, whatever. So you're going to get answer. So like this is what we've got. So I think this compound of the thing can be made more technical. I still make it more technical, And there was something I wanted to say about that, but I think I've forgotten. So if I remember in the next class, but what I'm just trying to like let you guys know is that I make it more technical. So If let's say the examples that we did not simple interest, I think I remember it now. The examples we did not under simple interest, where we're looking at 62 day treasury bill or something, one money market question like that. So and then we had to apply the formula of simple interest because the interest rate was annually, right? But if what if the interest rate was not annually, right? What if the interest rate was not annually? What if it was compounded like maybe quarterly? All right. What if it was compounded quarterly? Right. So in that case, I think we might have to use compound interest formula to solve that. So that's what I'm thinking. Like for now, sometimes I just think a lot of things. For 62 days, then that's going to be 6 months if it was compounded twice. So that means your capital is made to worth more, like two times in a particular year. Alright, so I think the simple interest will not work because the simple interest is not looking at compounding, but now it's saying that it has been compound. Of course, even if you see compound, you already know what to do, right? Do it 62 day, but then if you've been told that it was compounded, twice, and that means we should use the compound interest formula. It can't be the simple interest anymore, even though it's not to a year, right? So that's what I think. You have things like that. All right. So like in the next class, we'll be looking at continuous compounding and discounting. All right. Thank you. Bye.